Today we will be discussing about moments. The term moment as used in physics has nothing to do with the moment used in statistics. The only analogy being that in statistics that we talk of moment of random variable about some point. The moments in statistics are used to describe the various characteristics of a frequency distribution like central tendency, measures of dispersion, skewness, and kurtosis. It can be seen that the formula for a moment coefficient is identical with that for an arithmetic mean. The identity has led statisticians to speak of the arithmetic mean as the first moment about the origin. Now let's move on to the definition. Let the symbol x be used to represent the deviation of any item in a distribution from the arithmetic mean of that distribution. The arithmetic mean of the various powers of these deviations in any distribution is called the moment of the distribution. So this is the definition for a moment, and there are two types of moment that you will be studying. One is the central moment and the other one is the row moment. Now the central moment is also known as moment about the mean, and it is denoted by mu r. Again, the row moment is also called as moment about any arbitrary origin, and it is denoted by mu r dash. Now let's have a look into the central moment. Now, central moments when it comes to the individual observations. Now let x1, x2, etc. xn be n values of a variable x. Then the formula for a central moment is given as mu r is equal to 1 by n summation x minus x bar the whole raised to r. Now here x bar is nothing but the mean of the values. And what is r? R takes the values from 0, 1, 2, 3, etc. up to n. Now, if I Now, I know that I know the definition or the formula for mu r, and in that if I give r is equal to 0, then what will I get? Let's have a look. Mu naught. Right, so this is called the zeroth central moment. And mu naught, what is mu naught? Mu naught is equal to 1 by n summation x minus x bar the whole raised to 0, which is equal to 1 by n. This term will become 1, so summation 1, which is equal to 1 by n multiplied by n, which is equal to 1. So we get a result as mu naught is equal to 1. So this is a very important result. And what is mu naught? Mu naught is the zeroth central moment. Okay, so similarly what we will do next is I'm going to give r is equal to 1 in my formula. So what is your formula? This is your formula, that is mu r is equal to 1 by n summation x minus x bar whole raised to r. Now in this formula we will mark this as equation 1. In this formula I'm going to give r is equal to 1, and let's see what we'll get. So we get mu 1 is equal to 1 by n summation x minus x bar the whole raised to 1, which is equal to 1 by n summation x minus x bar, which is equal to, what I just did is I took this 1 by n and summation inside this brackets, and so that I get two terms over here. So the first term is 1 by n summation x, which I hope you all know what is it. It is nothing but the arithmetic mean x bar, so I wrote it over here. What about the second term? Second term is 1 by n summation x bar. Now x bar is a constant, so I took the constant outside, so x bar multiplied by 1 by n into summation 1. What was that? N itself, so that cancels, and I get this as what? X bar minus x bar, which is equal to 0. So from this I get my mu1, the second result, mu1 is equal to 0. Now this is also a very important result, that is the first central moment, first central moment, which you denote it as mu1 is always 0. This is applicable for any data set or any number of observations that you have. Okay, so next what I'm going to do is I'm going to give r is equal to 2, and I'm going to check what is the second central moment. So my second central moment is denoted by mu2, which is equal to 1 by n summation x minus x bar the whole square. Now I hope you are familiar with this formula. What is this formula? This is nothing but your variance. How will you denote your variance? Sigma square. So this is also a very important result. Now what is mu2, or what is second central moment? It is nothing but your variance itself. Okay, now we will move on to mu3. So how will I find mu3? Just put r is equal to 3 in your formula or in equation 1, and then you will get mu3 is equal to 1 by n summation x minus x bar the whole cube. Okay, so that is the another result. Then what is your fourth central moment? Fourth central moment is mu4 is equal to 1 by n summation x minus x bar the whole raised to 4. So in short, you can also find the fifth, sixth, and so on. But here, regarding your semester, you need only you just study the first 4 moments. Okay. Now, next what we are dealing with is again central moments, but when you are given with the corresponding frequencies of each values. Okay, so if you have the frequencies, if you have some values, and if you have the corresponding frequencies, then what will you do? So this is what we are going to study. So let x1, x2, etc., xn be n values of variables x with corresponding frequencies f1, f2, etc., fn respectively. Then the moment about mean. Okay, so instead of saying central moment, you can also say moment about mean or central moment. How will you denote the central moment? As mu r. So the notation has no difference even if you introduce a frequency, but the formula will be different. What is the formula over here? 1 by n into summations f x into x bar the whole raised to r. Okay, or you can write it as like this. Now that is according to your will. Okay, now we will move on by introducing r is equal to 0. We will find what is mu0, mu1, mu2. Okay, so let's have a look what we will get when we give r is equal to 0. So in the first case, when we put r is equal to 0, what will you get? When r is equal to 0, you get mu0, which is the 0th central moment. And what is that? 1 by n summation f into x minus x bar the whole raised to 0, which is equal to what? Summation f divided by n, that is equal to 1. So this, from this also you get mu0 is equal to 1. So what does that implies? Any data set or any set of observation you get, the first the 0th central moment will be always equal to 1. And what about the first central moment? The first central moment mu1 will be equal to 0. This you can try it for yourself. Okay, and what about the second central moment? Second central moment is nothing but your variance, or you can denote it by sigma square. Then you have mu3 over here. When you put r is equal to 3, you get mu3 is equal to 1 by n summation f into x minus x bar the whole cube, and so on. Okay, so here you can find, if you want, you can find mu4 also. Mu4 is 1 by n summation f into x minus x bar the whole raised to 4. Fine. Okay, now let's move on to row moment. Now let x1, x2, etc., xn be n values of a variable x with the corresponding frequencies f1, f2, etc., fn. Then the rth rth row moment of any value is denoted by mu r dash. See, for the central moment it was what? For the central moment, the notation was nothing but mu r, but for the row moment it is mu r dash. Okay, and the formula is given as mu r dash is equal to summation f into x minus a the whole raised to r divided by n, which is equal to summation, instead of writing x minus a, okay, instead of writing x minus a, you can denote it by d. So I have written over here f into d raised to r divided by n. So again, what is a? What is a? A is any value. Okay, so any value, or yeah, so that is what we have to okay. Now what I'm going to do is I'm going to put different values for r, and I have to check the 0th row moment, first row moment, second row moment, and so on. So when I put the r is equal to 0, what will I get? Mu 0 dash, right? So what is my what will my formula become? Summation f into x minus a the whole raised to r divided by n, which is equal to what? This part, x minus a the whole raised to r, or x minus a the whole raised to 0 is 1, so I get summation f divided by n, which is equal to n by n, which is equal to 1. What about mu 1 dash? You put r is equal to 1, you get summation f into x minus a divided by n, which is equal to summation ft divided by n. What about what will you get when you put r is equal to 2? Mu 2 dash, which is equal to summation f into x minus a the whole square divided by n, which is equal to summation fd square divided by n. What about the case when you put r is equal to 3? You get this value, and when you put r is equal to 4, you get this value. Fine. Okay, so that was about your row moment. Now the important relationship that you have to find out over here is, this is really important, you have to find out a relationship between the row moment and the central moment. Now what is row moment? Just to refresh your memory, what is row moment? Row moment, so what is row moment? Row moment is nothing but moment about moment about any value or arbitrary value. Moment about any value or arbitrary value is called a row moment. Now what about central moment? Moment about mean is called a central moment. Fine. Now let's have a look. Let's see what relationship lies between let's see whether there is any relationship between the row moment and central moment. Okay, so for that I'm going to take some values like x1, x2, etc., xn, n values from the of the variable x, and it has some corresponding frequencies like f1, f2, f3, etc., fn. Now I know that the formula for central moment is what? Mu r is equal to 1 by n summation f into x minus x bar the whole raised to r. Now you have to consider the formula for mu r dash. What is the formula for mu r dash? That also you have studied by now. What is that? 1 by n summation f into x minus a the whole raised to r. Now you have to consider a case when r is equal to 1. Okay, now when r is equal to 1, let this be equation a, when equation B I will consider. So so let this be equation B. So when you put r is equal to 1 in this equation, what will you get? Mu1 dash is equal to 1 by n summation f into x minus a the whole raised to 1. So I just didn't write this one before. Okay, so that's it, and that is equal to 1 by n summation. I took the summation and 1 by n inside this brackets. Okay, so what will I get? 1 by n summation f into x minus summation f into a divided by n, which is equal to, what is this? 1 by n summation fx. What is this? Are you familiar with this? Yes, this is nothing but your arithmetic mean when arithmetic mean when there are frequencies, right? So this thing you have studied in your last chapter. So what is this? This is nothing but x bar minus a is a constant. I don't know the value of a, so I take that a outside. Summation f divided by n. Now you know what is summation f. What is summation f? Summation f is equal to the total number of observation, right? Total observations. And what is the total observations? Total number of observations over here is capital N. So instead of summation f, you can also write it as capital N. So a into n by n. So this and this gets cancelled. Finally you get x bar minus a. Therefore mu1 dash is equal to x bar minus a. So in some cases what happens is that sometimes the investigator may take a is equal to 0. So if this happens, then mu1 dash will be equal to what? Your x bar. Fine. Okay. So these are some of the things that you need to establish a relationship between the row moment and the central moment. So now our derivation starts. So our derivation starts with what? The formula for the central moment. Now you know the formula for the central moment. What is the formula? Mu r is equal to 1 by n summation f into x minus x bar the whole raised to r, which is equal to, now in the next step what I'm going to do is I'm going to introduce an a. So whenever you introduce a value to the equation, what you have to do? Yes, you will have to subtract that same value or same variable in that equation, right? So that is what I'm going to do now. So 1 by n summation f into x minus a minus x bar minus a the whole raised to r. Okay, and this is equal to what? 1 by n summation f into this term is written like this itself, x minus a minus, what about x minus x bar minus a? I hope you all know what is x bar minus a, that we have derived it a bit earlier. What was that? Mu1 dash. So instead of x bar minus a, I just wrote mu1 dash the whole raised to r. Now what I'm going to do is I'm going to apply the binomial theorem. I hope you all know what is binomial theorem. So for those who don't know about binomial theorem, I have written it over here. What is it? X plus a the whole raised to n is equal to nc0 x raised to n plus nc1 x raised to n minus 1a plus nc2 x raised to n minus 2 a square plus etc plus ncn a raised to n. So this is the binomial theorem that you have studied in your higher secondary classes. Okay, now you are going to apply this theorem in this equation. Now when you apply this theorem in this equation, just see how can you apply this theorem in this equation. You have an x minus a over here, x minus capital A. So this term I'm going to take it as, this whole term I'm going to take it as x. Okay, I'm going to consider this as x, which is over here. Then what about mu1 dash? A, I mean small a. Okay, now let's see how I can expand this term. Now this is in the form of x plus x minus a, or you can say that it is in the form of x plus minus a the whole raised to r. Okay, so this and this, do you find any similarity over here? Yes. So that is how you are going to apply the binomial theorem. Now let's have a look how will you apply the binomial theorem? So I'm going to do the expansion. Now here I have 1 by n summation f over here, so that I'm going to write it like that itself. I'm not going to make any changes over there. What I'm going to change is this term in the brackets. Okay, so there I'm going to apply the binomial expansion or your binomial theorem. Now what is that? Instead of nc0, instead of n over here in the power, I have r, right? So what I'm going to do, instead of nc0 I will write rc0. Okay, then let's have a look at the next term. What is it? X raised to n. So what do I have over here? X minus a, right? So instead of x, I just write it as x minus capital A raised to n raised to r. So that is the first term of the expansion. Now regarding the second term, any guesses? Instead of n you can write r c1. Instead of x you can write what? X minus capital A the whole raised to r minus 1. What about this a? Mu1 dash. Just have a look whether this is what you get. Yes, rc1 x minus a the whole raised to r minus 1 mu1 dash. See, there is one difference that is happening over here, that is regarding the sign. So here I have a negative sign over here. Why did you get a negative sign over here? Yes, because your second term is a negative term, unlike the term in your binomial expansion or binomial theorem. Here you have a positive term, but since you have a negative term over here, that is the mu1 dash is a negative term, the second term will be negative in sign, or it is said that the alternative terms will be negative in. Okay, now what about the third term? rc2 x minus a the whole raised to r minus 2 mu1 dash the whole square, minus alternative term rc3 x minus a the whole raised to r minus 3 mu1 dash the whole cube. Just have a look at these terms. Now it is decreasing in power, this term x minus a. What about mu1 dash? It is increasing. Okay, plus etc. Okay, I forgot to write this. It doesn't end in the fifth term. You have some other terms also over here, so you need not write that. Just put it as plus etc. Okay, or you just write it as minus. Don't write plus, minus etc. Fine. So this is the expanded form. Now what I'm going to do is I'm going to take this 1 by n summation f inside this bracket and see whether what I get. Fine. So I take this 1 by n summation, I took this 1 by n, 1 by n summation f inside the bracket, and what I did is that I took the rc0, which is a constant outside. Okay, so for each term I applied this and I took the constants outside. So let's have a look at what change we have done over here. So rc0 is taken outside, then I get 1 by n summation f into x minus a the whole raised to r minus rc1 mu1 dash 1 by n summation see, mu1 dash is also a constant, that is why in the second term I took mu1 dash also outside. Okay, 1 by n summation f into x minus a the whole raised to r minus 1 plus rc2 mu1 dash the whole square is a constant, I took that outside, 1 by n summation f into x minus a the whole raised to r minus 2 and so on. Okay, now rc0, let that be there, you don't have to change anything over there. What about this term 1 by n summation f into x minus a the whole raised to r? What about that term? Okay, what about this term? Yeah, do you have you seen this somewhere? Yes. What is this? This is nothing but mu r dash. Fine. Now You have the second term as RC1 mu1 dash 1. Now what is this? 1 by n summation f of x minus a whole raised to r minus 1. It is nothing but mu r minus 1 dash. What about this term? Mu r minus 2 dash. And what about this term? Mu r minus 3 dash, and so on. So how can you write finally mu r as mu r is equal to rc0 1 by, sorry, you don't have to write this 1 by n, rc0, instead of this formula you can write it as mu r dash minus rc1 mu 1 dash mu r minus 1 dash plus rc2 mu 1 dash square. Instead of this big term you can write it as mu r minus 2 dash minus rc3 mu 1 dash cube mu r minus 3 dash plus etc. Okay, so now you have what? The relationship between the central moment, and what are these? These are row moment, right? So this is the relationship between the central moment and row moment. Now what I'm going to do is I'm going to put, if I have I'm going to put the value for r, different value for r in this particular equation. Let this equation be equation C. Okay, so if I put r is equal to what, 0, I get mu 0 as 1. So this I need not check over there. If I put r is equal to 1, I get it as 0. Then what about mu 2? If I put r is equal to 2, I get 2z0 mu 2 dash. See, if r is equal to 2, you get 2c0 mu 2 dash minus 2c1 mu 1 dash. Then what about this? Again a mu 1 dash you get, plus 2c 2 mu 1 dash the whole square, you get mu 0 dash minus so on. I'm not going to expand anymore. Now with this I'm going to do something. What I get is 2c0 mu 2 dash minus 2c1 mu 1 dash mu 1 dash. So and here I get 2c2, which is 1 mu 1 dash square mu 0 dash. Now mu 0 dash is 1. Okay, so what will I get? Yes, I get, finally simplifying this whole all the three terms, I get mu 2 dash minus mu 1 dash square. So mu 2 is equal to mu 2 dash minus mu 1 dash the whole square. This is also a very important result. In this way you can find out with the help of equation C, you can find mu 3, mu 4, etc. Okay, so I hope you have understood the class. Thank you.